So lesson 7, page 249. So the first example here, they gave us a diagram, which is good. Note, in math, nothing is ever drawn to scale. Generally speaking, it's like proportional, but not to scale. So it should give you like an idea of like one side is bigger than the other kind of thing. So in this one in particular, QS is 32 millimeters. So let's go on our diagram and let's label that QS is 32. PQS is 50 degrees. So that means this angle here is 50 degrees, and then RPS is 61. So up here is 61. Remember, the letter in the middle kind of indicates what angle you're talking about. At the end of the day, we want to find out what QR is. So we need this whole distance. In order to figure out the whole distance, I need this partial distance. The catch on this one, though, on this triangle where that partial distance is, we only have one piece of information. You always need 2 out of the 3. So we need to figure out a second piece of information. Anyone, go off mute, be brave. What second piece of information can I figure out? So what can I solve for? So what's like our step 1 in solving this? Yes, we totally could solve for the SPQ angle. Totally. It's not going to be helpful though. Right? Like I can tell you right away that's going to be 40 degrees because a triangle adds to 180. Knowing that though doesn't help me. Good. Good. So we're going to solve for PS because on that triangle I know that this is 50 degrees and this is 32. So we can solve for our opposite side. So we're going to do the tan of 50 is equal to that PS, our adjacent side, over 32. So then into our calculators, we're going to do 32 times the tan of 50. Which gives us 38.14. So now using that information, we have a height. So now we can actually solve. So RS, that triangle is this one, where we want to solve for our opposite side again, but using our 61 degrees and our 38.14. So we're still going to use tan, but now it's going to be the tan of 61 is equal to our opposite, or unknown, over 38.14. So remember, we always want to round at the very end. We keep 2 extra decimal places. So that's why I'm using the 14, because they want the nearest whole in the end. So now I do that 38.14 times the tan of 61, and we get RS to equal 68.79. Am I done? Someone be brave. Good, right on. We want to find that whole length. So we want RQ. So we have to go to the 68.79 plus 32. They say round to the nearest whole, so that's 101 millimeters. Matthew, you should be taking notes with us, are you? It looks a lot like you're in bed, just snuggled up in a blanket. You should. Are you? Okay. Okay, let's try this next one. It's a similar question, very similar, but different pieces are given. So at the end of the day on this question, we want to know the angle BEC. So we want to know just this little corner up here. Let's call that X. Again, that triangle, we only have 4.6 in it. So then we would have to use our other triangle to get that information. So we're still in this question actually going to start finding out that height. Okay, I want you guys to try to solve for that height all on your own. So just try for EC on your own. I'm going to take away my screen so I can fill it in because I want you checking it on your own, and that way you can check with mine afterwards. Hey, who wants to be brave and share their answer? Just for the height of EC, so just that vertical height. I got 2.3. So we should be doing 3.7 times the sine of 39. And you still get 2.9? Did you do the sine of 39 and then round that answer? But still. Enter it again. Yeah, maybe you just like, I don't know, that's weird for you to round differently. You did it on your graphing calculator too? Okay. Okay. Yeah, go ahead. Okay, so now on our second triangle, we have that piece of information that we're given. So x 2.3, 4.6. Which trig function am I going to use to solve for x? Good. So we have adjacent and our hypotenuse. The cosine of x is going to equal adjacent 2.3 over our 4.6. So this is where we have to use our inverse. So we go inverse of cosine of 2.3 divided by 4.6, and we get 60 degrees. So those two types of questions aren't bad. I would say that's like a really good like level 4 question. So there's two parts to it, a little bit more problem solving, a little bit more interpretation. The next page, we're going to get into our level 5, 6 questions here. So this is similar to the one we did last class, but just a lot of information, has been taken away. So in this one, we have two buildings, a Metro building and the Gamma Pro building. I'm not going to read this question out loud for you, but then it says from the top of the Metro building, the angle of elevation at the top of the Gamma Pro building is 24 degrees. This one I find kind of weird, and again, this question comes up a lot. This here is the angle that they're talking about to be that 24 degrees. Has to be with a horizontal. The angle of depression to the foot of the Gamma Pro building is 56. So here is our 56 degrees. And then the buildings are 45 meters apart. So a lot of mathematics to make questions easier is the visual part. So if my buildings are 45 meters apart at the foot, they're also 45 meters up here. The other piece of information that's given without being explicitly said here, our angle of depression is always equal to our angle of elevation. So that means that this angle here is also 56 degrees. So it's like that's the bonus information that was sneakily shared with us. At the end of the day in this question, they want us solving for the heights of both buildings. So if we solve for this distance here and this distance here, we're going to get the 2 because y is going to be our height of our metro building as well. Knowing that, we have a couple of triangles we can use. So to find that like little bonus extra height, that gamma pro is bigger than metro, we have this little triangle where this is 24 and 45. And then to solve for y, we can use this triangle where this is 56, 45, and y. Could you have used the like mirror image of this one where it's this side of it? Totally. Y is still y. That height is still going to be the same height. It's just 2 different perspectives to do it. So going to solve for x, we're going to use tan. So the tan of 24 is equal to opposite over adjacent. So then I'm going to get 45 multiplied by the tan of 24. Which gives us 20.04. And then on this one, we're going to have, again, the tan of 56 gives us y over 45, opposite over adjacent again, so then y is equal to 45 times the tan of 56. Am I done on this question?
No, we still have to add them.
Good, right on. So we know our metro building then is just the y. So they said the nearest whole meter. So our gamma pro building, sorry, our metro building is going to be just 67 meters. And then our gamma pro is going to be the 20 plus 67 because I know that rounding is okay. So then we get 87 meters for our gamma pro. It's really good on questions like this to pause once you're done them to be like, have I actually answered the question or am I just choosing to be done at this point? So our last question that we're going to go through is a bit of a doozy, quite frankly. What's really hard about this next one is that if you're not a visual person, it's hard to see the different triangles you need. So I'm going to go through it as best as I can. We're given kind of this weird object. I'm going to think of it as like a ramp. So I can see that the front of it's lower than the back of it. So it's like a block or a ramp. HD and GC, so my back measurement here is 5 centimeters. So let's label all of these measurements to help us out. EA and FB, so our front measurements are H2. AD is 6, and AB is 8. So what that means is over here is also 6, and back here is also 8. So we have some pieces of information. The 4 rectangles in this one, I'm just going to talk about these. So the 4 rectangles we have are our very back one, like this back vertical piece. That's a rectangle. This front vertical piece. And then we have like the top of the ramp. And then you have the bottom of the ramp as well. Rectangles, super helpful in this unit because a rectangle is composed of 2 triangles. So it's good to take a second when you're given an object like this and think about that doesn't have any clear triangles. Okay, are there rectangles I can use? So our first question, what is the measure of HEA? So that's like this angle right in here. Let's turn this object and look at just the side. So we're gonna have, really, we're looking, draw this a little bit smaller. This is the side of our object. So this was H, D, which is 5, 2, E, A, 6. So that's our information we've been given. We are looking for this angle here. Does that diagram make sense with everyone? Yes? Thanks, Andy. Okay, so from here, I'm going to manipulate this a little bit more because right now I have no triangles. We're in a trig unit. Let's think through this logically. I have to have a right triangle. So if I draw a nice little dotted line going across here, I can form a right triangle. I have a perfect rectangle on the bottom. This is going to be 2, and therefore this is 3 because 2 plus 3 gives us the 5 of that total height. By drawing that rectangle, I also now know that this is 90 degrees. So really, I just need to figure out this little angle here to figure out the entire thing because the corners of a rectangle are each 90 degrees. So now, what we're left with is I have this triangle. This is my angle X. This is 3, and this is 6. Not a hard question now. So now I'm going to do the tan of X is equal to our opposite 3 over our adjacent 6. So X is then equal to the inverse of 3 over 6. So I get 26.57 degrees. Don't forget we want the entire angle though. So angle HEA, we have to add our 90 degrees to it. Which gives us 117 degrees because it wants the nearest pole. So that one's a little bit hard because you have to think about it differently. Steadily gets harder and harder with the next 2 parts. I'm going to just turn over. So then it says calculate the measure of angle HFE. So HFE, sorry, I have to zoom out quite a bit so you guys can see it both. So HFE, we're looking at the top of this. So if I think of like the top of my ramp, I have H, G, this is 8, E, F, 8, 6, and 6. So the angle they're asking us for is if I was to draw a diagonal going across here to here. So this is our angle, let's call it Y, just to make our life a little bit easier. Sorry, my apologies. We don't know that this is 6, do we? No, it was 6 on the very bottom. It's a slant. We don't know that. So on this triangle, I have only one piece of information. I need to solve for that HE measurement. So if I look at that side that we just had drawn out, that connects that HE onto it, the triangle we were just using, this is that point I made up, so there would be like the rectangle below. We knew that this was 3 and this was 6. Can I solve for that HE length? You guys are silent, but yes, we can just use Pythagorean's theorem. So I have a right triangle. We need to solve for our hypotenuse. Does that make sense where that side is coming from on my diagram? If I drawn this out well enough, does that make sense how I've manipulated it? Someone nod or shake your head. Yes. Okay, so because you have to like turn these things, we can figure it out. So Pythagorean's theorem, I'm going to get 3 squared plus 6 squared equals our unknown. So I get 9 plus 36. I will have to square root this. 49, the square root of 49 is 7, so we're going to be close to 7, so 6.7. So we just found that this length here is 6.7. So now I have a nice triangle where I know two sides, and I need to solve for an angle. So we are going to use tan. So tan of y is equal to our opposite side, 6.7, over our adjacent side of 8. And when I do that, we get a nice 40 degrees. So tricky on this one to make that connection to solve for HE, which makes that one quite hard. Okay, this last question is our bit of a doozy here. So we want to find the angle HBD. So I'm going to go back to my diagram here. I'm just going to erase all of the rectangles I drew. So HBD is like an interior angle that they're making up to be here. So it's like slicing through this object to solve for that angle. Well, that being said, on that triangle, I'm just going to do mine to the side so you guys can keep seeing this image. The triangle of HDB, we currently know nothing about. That's our x that we're trying to solve for. So I need to figure out ways I can get those pieces out. I need to find two sides. We do know something, my apologies. We know HD is 5. So we need to find this unknown, DB. So that DB measurement, this is the bottom, or like the floor of my object. I have A, B, D, C. I know that this here is 8, and this here is 6. DB is right here. So we have a nice triangle here. Does anyone know off their top of the heads? I have an 8 and a 6 in my triangle. What does my hypotenuse have to be?
7?
No.
Probably not. It's the largest of
No.
this is the largest.
So we know, do you guys remember 3, 4, 5 is a perfect triangle? So if I have 6, 8, what is my last one then? 10. Good. So 6, 8, 10 is another Pythagorean triplet. If you remember that, if you just knew it off the top of your head, I would give you full credit for writing that down. If you don't, go through it. So we're going to get 6 squared plus 8 squared equals C squared. Oops. 36 plus 64, 100. So then 10 is C. So now we know our other unknown. So from here, I have opposite, I have adjacent. We're going to use tan again. So the tan of x is equal to our opposite side 5 over our adjacent side 10. I'm looking for an angle, so I have to do the inverse. Round it to the nearest whole, 27 degrees. So that question's really hard, a lot to visualize, a lot to take in, pretty tricky. So that's it that I'm going to go through. So for the rest of class, you have lots of time until 2:30. So you have 40 minutes. I have 5 questions is all that I would like you guys to be working on. And then these 5 questions, you can do these pretty easily. You're pretty set. Next week, we're going to have time to do our review booklets and study. I've already posted those. They're on the calendar and under Apply and Master, I think, on Manage Back. Any questions for the group? I am